So I showed you guys last time the geometry of the Earth, and I did it visually, showing you that I didn't use any irrational numbers, that basically we just took this 22 by 7 system here, and using pi increments alone, we just increment these numbers each by whether it be a pi or a pi 2 increment, and we get these sizes here, or these divisions that go within here all the way up to 2 pi. And so if we take a look at the square roots of 2 down here, we can see that there's no irrational numbers used here either. The only thing that's actually happened is we've taken these numbers up at the top and we've decreased them all by 10%, and in some cases we've increased them by 10%. And this actually gives us the values of the square root of 2. Well, there's some stuff that's been bothering me lately because when I take a look at these trigonometry functions like tangent and things like that, these things return values in radians. And radians are a function of pi because 1 radian in degrees is actually formed by... If you take a look at this right here, what it does is it uses pi. And the pi version that they're using is the one that creates all this noise I've been telling you about, and it does not show harmony in number. So when you get a value returned in radians, the value returned in radians uses this noisy version of pi that doesn't keep the harmony in number. And so what I decided to do was take a look at how they're coming up with these radians real quick, and I wanted to backwards engineer this so that instead of it using their version of pi, that it's actually using the 22 over 7, which is the version that I've been showing you that doesn't really use any irrational numbers at all. It just uses a number set and pi increments, as well as the square root of 2. So in order to do that, what I did was, and I actually discovered something kind of interesting in the process. Okay, so first of all, let's take a look at their version and where I found issues with it. So example, here's pi, okay? So this pi that you see right here is the function of pi. If you notice right here it says equals pi in parentheses. That's what you get. So if you take the reciprocal of that, and we'll just do it this way. So we take pi and then we take the reciprocal of that. You can see it's this number right here. So that number times 180 should equal the amount in radians you get in degrees, right? It's equal to the same thing. So if we take a look here, this number right here in degrees, 57.296, should be, if you take a look at what they're going to do right here, so they take that, which is the radius, and what they'll do is they'll stand it up at a 90-degree angle, and then they'll curve it over the arc. So it's supposed to be the same, right? And that turns out to be 57.296 degrees if you use their version of pi. If you use the version of pi that I think is the correct version, that doesn't happen. So anyways, so if you take this number right here, which is the reciprocal, right here, and you multiply that times 180, then you get their version of what the degrees would actually be. So that's 1 radian is equal to 57.2957 degrees using their version of pi. Okay, so if we take the reciprocal of that, we get this number right here. Okay, now we know that the tangent of 45 degrees is supposed to be 1. So therefore, if we take a look at the tangent of 1 degree, and if you notice, it looks roughly the same, right? But if we take that number and multiply that number times 360, it looks like 2 pi. But it isn't. It's not 2 pi. It's a mismatch. If we take this right here and we multiply it times, which is the tangent of 1, and we multiply that times 360, we get this number, which looks like 2 pi. We divide that by 2, and we get this number. If we take that number and divide it by what we get for pi normally, we can see that there is a difference. And it's this close, which means that if it's this close to the original pi, then obviously the intention was to be the original pi. There's no other reason for it to be within 1/10,000th of a decimal right here. We have 1, 2, 3 places. So I have a big problem with that. And so this is what I've done up here. So let's take a look at my version. And I want you to take a look at the numbers here that are happening and versus the numbers that you see up here. So if we take 22 divided by 7, and we take its reciprocal, and its reciprocal looks a lot nicer, we multiply that times 180, we get a slightly different, and instead of 57.2957, we get 57.272727, right? So if we take that number and we take its reciprocal, we get this. If we multiply this times 360, then we get something that looks a little bit more like 2 pi. If we divide that by 2, then we actually get the 22 over 7 because, and we know this because if we take this number here and we multiply it times 7, we get 22. And so the match here is a 100% versus something that's slightly off using their tangent function. So if anything, the problem is consistency. Okay, so regardless of how you look at it, it seems that what they're showing here is that there's an inconsistency in what their tangent function is presenting versus what you get with their pi function. And I have no idea what they're using to actually derive the number for pi that keeps running on and running on. Like I said, at some point there's a sacrifice to it being exact with your measurement versus keeping harmony with number. And as you can see right there, the consistency also has issues. So what I decided to do is kind of show you. So this right here, you guys have probably seen this before. And these indentions kind of remind you of what the pyramids look like on top, kind of the 8-sided looking pyramid. But what these actually are, these are actually rhombuses that I've shown you before. These rhombuses have a ratio that is a pi over 2 ratio, or excuse me, a pi over 4 ratio. So for example, 594 by 756, which is like an 11 by 14. So this number here, this degree here, represents 51.84, and this right here represents 90 minus 51.84, which is 38.16. So here's the way we derive it using the 22 over 7. So the 51.84 is 22 over 7, which is equal to this number. Pi over 4 is equal to that number divided by 4. So if we want 1 radian, instead of using their system, we use this version of pi. Our 1 radian is 57.272, etc. If we take the reciprocal of that, okay, and then we multiply it times 51.84, then this is the number we get in radians. And we know this is correct because if we take this and we take a look at our angle, we can see that 51.84 degrees is 0.904779 using their version of pi, but using this version where we have this radian, it's 0.90514. You can see it still uses the sevenths. So if we take their version of degrees and we multiply it by this ratio here, we actually get 51.84, which is correct. And then if we take the calculator using their version of pi just to check our work here, because 51.84 degrees, if we do a tangent of that, so 51.84, 1.272600 using their version, but using this version, which is the 22/7, we get this for a value, which is extremely close, but it exactly equals 14 divided by 11, because if we take 14 and we divide by 11, we get the exact same number I showed you here. The reciprocal of that number, okay, so this is the 51.84, so the tangent of that is right here. So if I show you this part that you see right here, that's 51.84. So now we want the reciprocal of that. And so what we're actually doing is finding where to square the circle. So if we take the reciprocal of this number right here, that's actually pi over 4. Okay? So how do we get that? Well, the reciprocal of 14 over 11 is 11 over 14, which is actually pi over 4. So we take 1 and we divide it by 1.272 and we get the pi over 4 value. So we actually got our reciprocal showing it's 11 over 14. So then we take the reciprocal of 1 radian, which is equal to the 57.272, and that's equal to this number, and we multiply that times 45. So let's do that real quick. So we have 22 divided by 7. Take that number, take its reciprocal, multiply times 180, we get our degrees, right? We take that number, we take its reciprocal, and we multiply it times 45, and we get pi over 4 times 4, and if we take the reciprocal of that, you can see the reciprocal is exactly the same as what we see here. So then if we look at 90 minus 51.84, that's equal to 38.16, and that's equal to this degree that you see right here. So we want that in radians, okay? So then what we do is we take the reciprocal again of this 57.272. So let's do that. So we have our 1 radian in degrees. We take the reciprocal of that and we multiply that times 3816. And that's what we get in radians. And we can check that because 3816 in radians is .666018. And this is the version using our version of pi. So we multiply that times our version of the radian, and we get 3816, which is what we have right here. So the tangent function that you saw down here, just to kind of show you that again one time. So the tangent of 45 degrees is 1, and 180 divided by 45 is 4. So that means there's 4 of them, right? But if we're using pi, pi is a smaller number, right? So pi is the arc, it's the 3.14 arc. So in that situation, we have a 22/7 situation. So we can take what we've done and we can work our way backwards and then prove how we derived what we did from the first thing and from the first place, because we can take 22/7 is pi. The tangent of 1 is equal to this right here, which is what I showed you. For example, if we use their version, if we take 1, which is the tangent, right, and then we take the reciprocal of that, that's what they try to give us, right? But you can see it doesn't match up. Ours does match up, which is the 57.272. So the tangent function that they're showing is not work. So we can take the reciprocal of that, and 1 radian is 180 times this number. We take the reciprocal of this number, which is pi, and we multiply it times 7, we get 22. So we can work ourselves in reverse, and we can derive how we got pi all the way to how we got radians, and everything works itself out just perfectly in both directions. The problem that I see with what they show us is that there's really no geometrical representation, there's no harmony in number, it's all noise, and the numbers don't match up between their pi versus their tangent function. So if I take the tangent of 1 and I multiply that times 360 and divide by 2, I get a number different than what I think we should get, because that's not pi, right? But if we use the tangent function as which uses radians, and we treat radians as 57.272, and we use it as a fraction, which is like the 22/7 fraction, then everything works out perfectly in both directions. So anyways, just some more information to show you. The next thing I'll show you guys, it has something to do with the square root of 2, and I can show you how it is derived, and also it's one of these other things they call it's a irrational number that you can never figure out, but I can show that it's the same as far as decimal places all the way up to the 10th decimal place. So I'll show you guys that in the next video. You guys take care, and I'll talk to you soon.